Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Deep Dive Performance Analysis with InfoSphere Optim Performance Manager. Our guest speaker today is Mr. Neela Madhavsuram, Senior Staff Software Engineer at IBM India Software Labs. Neela Madhavsuram is an IT specialist at IBM India Software Labs, Bangalore. Since joining IBM in 2001, he has held various roles from design and development of applications to working with legacy systems running on Z platform. He is currently working with the Optim Performance Manager development team in ISL. Prior to that, he was the part of the worldwide WebSphere Business Partner Enablement team. He has also delivered seminars and conducted workshops in management and leadership. So without further delay, I introduce you all to our guest speaker. Over to you, Madhav.
Thank you, Mohini, for that introduction. Let me start sharing my screen. And Mohini, you can confirm if you are able to see my screen.
It's still not shared.
Okay.
Now it is visible.
Okay, great. So good morning, good afternoon, and good evening to everyone from wherever they have joined. And thank you for taking the time to attend the session on understanding the features and the capabilities of Optim Performance Manager tool. And I'm part of the development team here in the India Software Labs at IBM. The agenda for today would be to go through the functional overview of OPM and introduce you to one of the dashboards called the overview dashboard, which gives an overview of the performance of the databases. And then we'll look at how OPM, the different screens, the dashboards and the reports could be used in analyzing some of the system level bottlenecks. And majority of them are in the disk space or the CPU, memory, logs and networks side of things for the databases. So that would be the agenda that we'll be covering today. Now, OPM works in an eco-space which is used to identify and diagnose problems. Now, there are 4 steps when issues occur. The first would be to identify the issue, diagnose the issue, solve, and then prevent it from happening in the future. So this particular slide talks about the monitoring and optimizing performance capabilities of the various Optim tools that IBM offers. The Optim Performance Manager tool, for which we are talking today, is useful in identifying and diagnosing problems with respect to performance issues for your database. There's another product called the Optim Configuration Manager, which also helps you in some bits to identify and diagnose problems. And to solve the problems, you have the Data Studio product. And for SQL query tuning or workload tuning, we can use Optim Query Workload Tuner or Pure Query Runtime products. And DB2 has something called as WLM or Workload Manager, which can be set up to have various SLAs attached for different kinds of workload, so that any performance hits on very important workloads is not hit upon during regular business hours. So this is the eco-space in which the Optim Performance Manager tool works. So let's try to understand the architecture highlights of Optim Performance Manager and what it brings to the table. Starting with OPM 4.1 version, we have moved to a client-server architecture which has a web-based user interface. The current version of OPM is 5.2 and version 5.3 is releasing in a couple of weeks along with DB2 Kepler. Optim Performance Manager does periodic data collection from the various monitored databases using in-memory metrics, event monitors, and snapshots to build historical repository of performance data. The collected data is stored in an internal DB2 database called the PerfDB or the repository database. And in the current versions of OPM, there is support for real-time viewing of performance data. The data that is collected by OPM is aggregated into 4 different levels. Out of the box, the default values for these various levels are 5 minutes for the aggregation level 1, 15 minutes for aggregation level 2, 1 hour for aggregation level 3, and a 1-day entry for aggregation level 4. What this means is, depending on how your monitor database has been set up to collect performance data, data would be collected every 5 minutes and an entry is made into the aggregation 1 tables. The least that we can go here is 1 minute interval, but the default value is 5 and the user can go and change it to a 1 minute interval. For aggregation level 2, data that has been collected over the last 15 minutes is aggregated into a single record and stored in the aggregation level 2 tables. Now this data, the historical data that is present in the aggregation tables, can be saved up to 2 years. That is, without performing any other settings, the data would be there in the performance repository for 2 years. So at any point of time, you can go back in history and verify what has happened to a database in terms of performance. OPM also comes with standard templates depending on the kind of environment that you have where your database is running. For business intelligence kind of setup, for OLTP, or if you have an application server that's running in your setup, we have templates which identify the key important metrics that would need to be collected in order to understand the performance issues for a database and how to prevent them. I'll move on to the next slide where we talk about the architecture of OPM and what are the different components of OPM that are available. OPM is divided into basically 2 different components. One is called the console server and the other is called the repository server. Now the repository server is the one which runs and picks up performance data from the various monitored databases. So the way data is collected would be based on using in-memory metrics or snapshot UDS or event monitors. And this mode is for databases which are DB2 versions 9.7 and above. For database versions below 9.7, that is 9.5 and 9.1, we use the snapshot UDS. Now the collected data, as I mentioned earlier, is saved in the performance repository database. And the console server provides the web interface that is used to configure anything that you have on OPM with respect to what databases have to be monitored, what metrics have to be collected, what is the time period for which you want the data to be collected, all that. And also, the web console provides you with something called as dashboards and reports to view the performance metrics in a usable fashion. Starting with OPM 5.3, which is releasing in a couple of weeks, we have embedded a subset of OQT to help users analyze any issues with SQLs and find out what issues it could be using the Optim Query Workload Tuner. Of course, if the user has a full-fledged client of Optim Query Tuner, even that can be used along with OPM to directly move from, view the SQL on OPM and move it directly to OQT and perform any analysis and tuning as well. So apart from these basic features, there is an additional component called the Extended Insight Client, or EI license, that can also be taken along with OPM. And this helps in analyzing not just the database issues, but also where different times are being spent over the entire stack of your application, network, operating system, the driver level, and other layers. Later on in the session, we'll show you the drawing and the dashboard, which shows details on what metrics Extended Insight brings into picture. So that's the architecture, basic components of OPM that a user would see. Moving on, the first dashboard that I'll touch upon is called the Health Summary Dashboard. Now, this is probably the first place that users might use to identify any issues for their various databases that are being monitored. So you will see various kinds of alerts that are thrown on this particular dashboard, and very easily identifiable in terms of red alerts or the yellow alerts where particular SLAs are being crossed. And whenever there are any alerts that are there, we can also set up notifications to be sent to the administrators or anyone else so that they can take necessary actions to mitigate that. So we can set up email IDs on OPM for alert notifications to be sent. Apart from this, once we identify a particular alert for a database in the various sections that are shown here, we can drill down further into identifying what exactly is the alert for and what action needs to be performed for that particular alert. So on the current screen that is being shown, we can see that there are some alert details that are being shown, and there are actions that are recommended. And the action that's recommended in this particular case is to move to something called the locking dashboard, because the alert that we have selected was a lock alert. And once we go to the locking dashboard, we can see complete details about that particular lock, at what time it occurred, what applications or what SQLs were running which went into the log, and various other details. And once we drill down into that particular lock, on the locking dashboard, you also have the facility to force the stopping of the application or the SQL itself in case it is currently running still on the database. Even from the locking dashboard, we can launch Optim Query Tuner to tune the query for any performance issues that are noticed. So having provided the functional overview of OPM, I'll now talk about one of the major dashboards that are provided with OPM, called the Overview Dashboard. Like the name mentions, it's basically an overview or a snapshot of various performance metrics for your monitored database. There are two different views that are available. The old one is called the key indicators, which we are still continuing to show that view. And there is also a new view called the at a glance view that is provided on the overview dashboard. Now this shows a summary of all the performance metrics categorized under workload or caching, utilities, or HADR, or system level metrics, or locking data, that is locking performance data for your monitored database. On this particular screen, you can also notice that there are a couple of places where it's showing up as red, which means there are some KPI violations that have come up. And these KPIs have been set by the database administrator for that particular database. And like I mentioned, we can always set up email alerts to notify the administrator or anyone else whenever these violations happen. And once you click on those alerts, you can actually get a bigger view and a time view over a timeline period, mentioning, okay, what are the issues that happen with respect to, let's say, the package cache hit ratio. Why was that alert raised and when the KPI violation had happened. So on a graph, we can actually see that the database administrator had set up 80% as the minimum level for the package cache hit ratio, whereas majority of the time in the 2-hour time slot that was selected, the package cache hit ratio was below even 70%, which is extremely low. So an alert was raised. Now, the second view that I mentioned, which is the at-a-glance view of the overview dashboard, which has been added from 5.2 onwards, it brings together more metrics collected under various sections for an at-a-glance monitoring. At the same time, you can also set baselines, meaning I can set up saying maybe from 2 p.m. to 3 p.m. on 6th of June, this is when my database has performed excellent. I'm setting up that as my baseline. And if I want to compare how the performance of the database has been between 3 p.m. to 4 p.m., I can then compare and see on this particular dashboard. So the moment we select a baseline time, the charts that are shown change their color from blue to the yellowish color, indicating that there has been some deviation with respect to that particular performance metric between the baseline and the current time slot. And then from there we can drill down further as to what value was there during the baseline, what value is there in the current time slot, and then we can drill down into various other dashboards into identifying what exactly the issue was and what should be done to mitigate that particular issue. On the top of the dashboard, you will also find a time slider for you to assist and help for you to select the time slot that is needed for checking the performance data. On the top left-hand corner of the dashboard, you also see something called as a view, and currently the screenshot is showing historical data. We can also pull it down and then identify real-time data information, wherein as and when performance issues are happening on the database, you see various performance metrics refreshed on the database. And how frequently this needs to be refreshed can be set on the dashboard itself. The next slide that I'll show talks about how you select some baseline time and how you can compare, or what kind of information is shown in the time slot selected versus the baseline time that was set up. So when performance behavior represents a good value on your monitored database, you lock that time period as a baseline. And then any of your future performance data, basically compare it with this baseline time. I think the screen is still refreshing, so I'll just wait till it refreshes so you can see what exactly I mean. Yeah, now I think it's up. So on the screenshot that is shown on the bottom right hand, you can actually see both the values at the baseline time as well as the values at the current time slides selected are both shown and any deviations, what is the standard deviation, what was the high value, low value, all those metrics are shown in the pop-up. I'll also talk about another dashboard which is called the SQL dashboard, where we have had many questions from earlier users asking about what are different things that can be done on the SQL dashboard. So the SQL dashboard comes with two tabs. One is called the top executions tab and the other is called the summary view tab. On the execution summary, we can see various SQLs that are being executed in a specific period of time and sorted based on various metrics. For example, you can sort and select saying, in the last 1 hour, what are my top 10 statements which have taken the longest CPU time, or which have been the ones which have been executing the longest, or which have had the most number of executions. So we can select these criteria, and then the dashboard displays your top 10, top 20, or top 50 set of SQLs. And then in the bottom half of the dashboard, there are details for that particular SQL in terms of what was the last execution time of this particular SQL, what were the execution times, how many rows were picked up for each fetched row, how many rows were actually read from the database, what was the I/O activity for this particular SQL over this particular time period that was selected, and any locking that occurred for this particular SQL, and all those details, minute details about that particular SQL statement are shown on this dashboard. At the same time, even from the SQL dashboard, OQT has been linked. So you can select the SQL and launch Query Tuner to analyze the SQL, any rogue SQL, and also do any tuning that would be necessary. On the top individual executions mode of the SQL dashboard, we show the top executions of a particular SQL. The summary tab was showing the summarized view. Let's say a particular SQL ran 100 times in the 1 hour time slice selected. The summary view would show you the summarized metrics information for those 100 executions. But on the top individual executions tab, it will show performance data for each individual execution of a SQL. And from there, we can even select what were the top individual executions based on CPU time or rows read and various other performance metrics. And even on this dashboard, you will find that we have two modes. One is called the historical data and the other is called real-time metrics. So the real-time metrics will show you data as and when it's happening on the database. So this is a non-cumulative view, and it's a snapshot of what exactly is happening at that moment on the monitored database. At the same time, historical data is still being collected in the backend. Now, the second feature of OPM that I'll go through is called the reports. So apart from the two dashboards that I mentioned, the overview dashboard and the SQL dashboard, there are other dashboards to look into information on locking in terms of workload, in terms of connections and database setup and other dashboards. Similarly, we have the reporting components where reports in HTML, PDF, PPT, and XLS formats can be created on similar lines. So reports are very useful for proactive monitoring and preventing problems. So you can generate reports at regular intervals of time to analyze any historical trends, planning your future workload changes that could happen, or any enhancements that you are performing with respect to your application or your database, or any such event. One very important report that is present pre-packaged with OPM is called the Performance Overview Report, which gives it's similar to the overview dashboard that we have seen earlier, and this is in the report format where you can select performance metrics for various sections. You can select which sections that you want the performance metrics for, and then generate the report. This could be OS-related information, tables, table spaces, buffer pools. You want details about packages that got executed or SQL statements. And this slide also shows the other reports that are available on OPM, which are the database configuration report, database manager configuration, connection report, SQL baseline comparison report, where you can provide 2 time slices, just like how we saw on the dashboards, where you can baseline a time period and then compare current metrics against the baseline. We can do a similar thing with respect to SQL statement execution on the SQL baseline comparison report. The storage group report is added for monitored databases which are DB2 version 10 and above, where we have the concept called as storage groups, where your table spaces are categorized in storage groups which are either addressed as hot, warm, or cold, depending on how frequently data is accessed from them and how quickly you need the data from those tables. So similarly, we also have something called the table usage report, the disk space consumption report, top SQL package report, top SQL report, and the workload manager reports, which will give you information on the different WLM settings that have been performed on the monitored database and how they are performing. Now, one thing that I mentioned about reports is that reports are very useful in proactively identifying issues based on historical data and then taking corrective actions for any future enhancements that are coming up. So starting with OPM 5.2, we have a feature called report scheduling, wherein from OPM itself you can schedule reports to be executed at regular intervals of time, and then users notified of the presence of that particular report, and they can go and download the report and view it. You wouldn't have to manually sit there in front of the console and then generate these reports. So you can set up reports to be generated periodic basis, various reports that I've just talked about, and execute them. The next feature that I'll talk about in OPM is something called as workload management. Like I mentioned, this is actually a DB2 feature. In short, it's called WLM or Workload Manager. And from the OPM web console, you can actually set up and configure various WLM objects on your monitor database. So this provides a good UI interface for you to create various WLM objects. Now, why would you use workload management? You would use workload manager so that various business objectives are met and the right workloads are given the right priority over the resources that are there. And this is also to ensure that there is no overload on the data server, and very important workloads get the right priority, right CPU amount, so that responses can be fast. The next screenshot shows the actual UI on how you can configure WLM from OPM itself. I'll just wait for the screen to refresh. So you can perform various things. You can set up superclasses. You can set up subclasses under those superclasses. Set up various KPIs for them. And say for this workload needs to be directed to this WLM through this WLM configuration, and this is the threshold limit I'm setting on this particular class. And then you can measure on the OPM screens the various performance objectives. If the performance objectives have been met, or if there's some further tuning that needs to be done on the WLM metrics, on the WLM objects that have been created. On the slide where I was talking about the OPM architecture, I mentioned about the extended insight or EI, OPM EI. Now this is where it gets interesting. Now typical database monitoring tools, all that they measure is what is happening in terms of the response time or performance at the database level or the operating system, or together both at the database and operating system level. But as you can see on this particular slide, what the user actually sees is all the time that was spent in the application layers, on the servers, at the database driver level, or at the network level. And this is where extended insight helps you identify all these times where exactly the particular SQL execution got stuck. Was it in the application server layer itself where the response took a lot of time for it to get rendered? Or was it a problem with the database driver? Was it the network issue? There was some network outages that happened because of which the SQL didn't get executed on time. Or was it at the database or the operating system level? So this is what EI helps you in identifying. The next screen, it talks a little more about the extended insight into transactions. So I can identify now from the OPM screens from which system, what kind of SQLs were fired, what happened to those, which SQLs there was a lock that happened, which users were using more time on the database server. All this information can be got from the extended insight dashboard on OPM. Have been met or not, and it also provides a summary for the various workloads, and even on this dashboard you can set up alerts. The next slide talks a little more details about what further details can be viewed on the extended insight dashboard. So on this particular screenshot, you can see that we have 4 different users that are associated with a SAP system, and for 2 of them there is an alert shown in respect to response time. We can drill down further and see why there was an issue with respect to the response time for these 2 users, and then we can go ahead and identify what was the cause of that particular issue. So as from the screenshot, we can see that one of the users is regularly hitting the threshold problem, and nearly 12% of the workload that is being executed is actually in a 7-minute time frame, and the most of the time is actually there is no activity that is going on. So using all these levels, the application team and the DBAs can then look at how these different SQLs are getting executed. Is there some change that needs to be done on the database itself, or in terms of workload manager structures that have been set up? Now from here, you can actually drill down further into the SQL dashboard, wherein you can actually view at the statement level what exactly is happening to that particular SQL, which is taking a lot of time that we saw on the extended insight dashboard. Finally, for this particular example that we have seen earlier, where one of the users was regularly hitting that performance issue with respect to response time, it turned out that for each row that was being used by that particular SQL, more than 700,000 rows were actually being read from the database. So now this becomes a very good candidate for using OQT, and we click on the tune button, launch OQT, and then perform query tuning to identify what can be, how this query can be made better. Do we have to add indexes on the table, or the query can be made better so that this performance hit will not be there in future? OPM out of the box has integration templates that are available for SAP and WebSphere workloads. So we can use extended insight to analyze issues with your WebSphere infrastructure, that is your WebSphere application server, or your SAP setup that you might have in your workplace. We can use OPM EI to actually identify any performance issues on various layers. For example, in this particular screenshot that will just come up on your screen, we are talking about 2 different application servers that are running, and we can see the number of connections that are coming into the database from each of those application servers. What is happening to the number of connections? Are there too many connections that are just waiting, or is there some SQL that is getting executed on each of those connections? I'm just waiting for the, yeah, I think now the screen has come up. So this is the screen that I was talking about, which provides integration to WebSphere workloads as well. And we can identify the various clients that the database has in terms of WebSphere application servers. Here we see 2 different application servers that are connecting to our database, and what are the various metrics for each of those servers, WebSphere application servers. Moving on, next I'll talk about how we can use these various OPM dashboards and configurations to identify some of the critical issues that you might encounter in your database. We'll first look at how to identify if there has been any disk bottlenecks that are noticed on your database. Now the first place that we would go to identify any issue is the overview dashboard. On the overview dashboard, as we have seen earlier, there are various sections which will provide us data categorized for various system metrics. And there we also use baselines in identifying, okay, between 4 p.m. and 5 p.m. today I have seen a disk bottleneck. Let me compare to this performance metrics between 4 and 5 p.m. against my baseline time and try to identify what has changed between my baseline and now that I'm now hitting the bottleneck in terms of disk. So on this screenshot, we can actually see that the I/O time has increased a lot. The baseline average I/O time percentage was 69%, whereas in the time slice that was selected, it is 96% I/O. So that is giving us a clue that there could probably be some issues with I/O, and hence this is probably a disk issue. And then we'll identify, drill down further and see what could have caused that. So from the overview dashboard, we move to the buffer pool and I/O dashboard. Because the performance metric that we saw, which was in terms of the I/O, is related, is shown in further detail on the I/O dashboard. Now we have noticed 2 things on this overview dashboard. One is the I/O time has increased from 69% to 96%, and second, the pool I/O has increased from 10.2 milliseconds to 17.6 milliseconds. And once we move from the overview dashboard to the buffer pool and I/O dashboard, we get further details on what was the exact activity that was going in terms of actual physical on the database. At the baseline time, we see that there were 36,141 physical pages that were read per minute, whereas in the current time slice it shows 212,406 pages per minute being read. This necessarily doesn't mean that there is an issue, it just could probably mean that there are more number of SQLs that could have been executed at this particular time. So the next thing that we will observe is the average read time per page. on this particular dashboard. It says that the average read time per page that has been fetched is also gone up. Now this is now a problem, because not just we are picking up more number of pages, but for picking up more for each page on the database, we're also spending much more time than earlier, which was our baseline time. The average read time now is 0.018 seconds, whereas on the baseline time it was much lesser. So once we go to the tab on the dashboard, which is called the table space, we'll try to identify if there has been any change on the table space that has been done which could have caused this. Again, we compare the current value with the baseline value, and we notice that there is no single table space where this particular issue is there. It's just that there are a lot many pages being picked up from each of those table spaces as compared to the baseline. So this is not a case where a lot of I/O is happening against only one table space on your table, and so yeah, nothing would probably need to be done on the table space side for this particular case. Then next we drilled on further into the tables tab to identify if there was any one particular table where this issue has occurred, because of which this I/O time has increased so much. We compare again, and then we see that the number of rows read in each of those tables hasn't varied greatly, the time slice that we have selected. And so this also doesn't look like an issue with respect to bottlenecks at the table level. Then we go back to the buffer pools tab to see further in terms of, okay, is there any, now that we have seen that there's no issue with respect to table space or tables, is there any issue with respect to the buffer pool hit ratio or the I/O ratios for those buffer pools? So on this slide, we see that the pool hit ratio is 78.31, whereas for the baseline, it was at 94%. So now we have identified one issue, that the buffer pool hit ratio utilization has actually come down from 94% to 78%, and this probably could be one of the reasons why the I/O times have so vastly increased. The next slide is just summarizing what all we have seen on this particular dashboard, which is the buffer pool and I/O dashboard, and how we can infer the cause of the issue. On the overview dashboard, we have seen that the percentage time spent on I/O has increased from 69% to 96%, from 10 milliseconds to 17 milliseconds increase in the average pool read time. The buffer pool and I/O dashboards show us details about the buffer pool reads per minute. And we also saw that the data hit ratio dropped from 94% utilization to 78%. And there was no apparent table space or tables which showed any hotspots with respect to performance. So some of the things that could cause this particular thing are probably some particular SQL has ran additional during this time, and it was a bad SQL wherein it was hitting that active table space again and again. Probably the buffer pool configuration, there was an issue with respect to the buffer pool configuration, and that's why the buffer pool data hit ratio has dropped from 94% to 78%. Now, when we go back on the buffer pool tab of the dashboard, we notice that for one of the buffer pools, which is the IBM default BP in this particular case, the size of the buffer pool seems to have changed quite a bit from the baseline time. Now, this could probably answer the issue that we have seen in terms of the buffer pool hit ratio getting reduced from 94% to 78% utilization. So this is one issue that we have seen, which is about how we can identify any disk level bottlenecks that we can observe on database performance using the OPM dashboards. It's currently 3:47, and I'll run through one more case to identify SQL issues before we end the session. I'm sorry, will I go through the locks on how to identify locks and what issues cause that particular lock, and see how OPM dashboards can help us. Now, we have from the overview dashboard, we moved to the workload dashboard because we have seen a few alerts on the workload section of the overview dashboard, and then we observe that in terms of transaction throughput and row throughput, there has been a sudden change, a drop or a sudden increase at certain instance of time. The screenshot shows that the rows read per fetched row didn't completely go to 0. Something was still being read, but which was much higher than the other times. So as you can see in this particular time slide on 27th May, somewhere between 1:10 p.m. and 1:23 p.m., there's been a sudden spurt in terms of the number of rows read per fetched row. Meaning for every one row that we want from the database, how many rows were actually read from the database itself into memory. This could possibly explain why there is a drop in statement throughput at that particular time, and also the transaction throughput at that particular time. The number of transactions that were processed had suddenly dipped. We'll try to identify how we can find out the root cause of this particular issue. So on the overview dashboard, we look at the time. There's a section called the DB2 time breakdown percentages, and again we compare the times that were there between the baseline time and the current time, and we observe that the baseline average was 4.74% in terms of lock weight, whereas the current in the current time slice that we have selected, it's about 46%, which is extremely high, which means there have been more number of locks that have occurred in this particular time slot. So on the bottom section of the overview dashboard, we go to the locking dashboard, wherein we try to find out more details on what exactly is happening, and then we find that the average wait time per lock has also increased from 115 milliseconds. It has now gone up to 2,359 milliseconds. And then we identify, go ahead and try to identify what exactly has caused this particular lock wait time to increase so much. The locking dashboard mentions that in the time slice that was selected, that 1 hour time slice that was selected, there have been 996 locking events that has happened in the particular case, a screenshot of which I have put on this particular slide. At the same time, in the baseline, we see that the maximum block time that was there was much lesser as compared to the current time slice. Right? The block time was just 0.02 seconds, whereas in this time frame we see that the maximum block time was 4.78 seconds. So there was some SQL or a set of SQLs that got blocked for a high amount of time, thereby showing the drop in the transaction throughput on the server. And from there, we'll go further into looking at the statements for that particular lock. So on this particular lock, what all statements are causing that particular lock, and then we can identify that this particular statement that we have identified in the lock has an isolation level of RR, which is repeatable read. But at the same time, in the next slide, we'll observe that the number of rows read in this particular SQL are more than 2 million rows. So when a particular SQL is reading about 2 million rows and we have an RR isolation level that is attached, this could cause certain performance issues because no other SQLs will be able to execute anything at that particular time, because more than 2 million records in your database are actually locked, and the other SQLs which might need to access those rows are waiting, and hence the increase that we see in terms of the lock weight. So in this particular case that I have taken, yes, the issue was with RR, and since the SQL was fetching a high number of rows, we probably might have to change the isolation level or change the SQL itself so that it doesn't read so many records in each execution. So I have taken these two cases, which is the disks usage and the locks, to showcase how OPM can be used to identify performance issues on your database and then help you in analyzing and then probably fix those issues. So in summary, the OPM overview, workload, and system dashboards are a good place to start to identify performance issues. And depending on the type of issues, we can drill down into further dashboards like the buffer pool locking or the logging dashboards. SQL statements can we can view them on the SQL dashboard and use the Optim workload query tuner to identify any issues with the SQL and then use OQT to actually tune that particular query. And extended insight gives a little more information with respect to your entire setup and not just the database layer itself. So having mentioned that, I now hand it over to Mohini so that we can take up any questions that might have come up.
Well, thank you so much for the insightful presentation, Madhav. I'm sure our attendees must be having some questions, right? I request the attendees to please send their questions now through the chat window so that the speaker can start answering them. Madhav, we have few questions from Santanu Gon. I hope you are able to see them.
Yes, Mohini. Okay, the question that I see is, how is OPM different from other off-the-shelf performance monitoring tools like Load Runner or open source tools? The second part of the question was, what are the protocols in terms of DB connectivity that OPM supports? The third part was, what are the levels of permission OPM needs for flawless activity? And the fourth part was, is DB2 the default database? What other databases are supported? So I'll probably start off with the last one, which is DB2 the default database? What other databases are supported? Yes, OPM currently supports performance metric collection for DB2 databases only. Going ahead, what are the levels of permission that OPM need for flawless activity? So OPM, there are two different kinds of users that you can set up on OPM itself. There is one user ID that you can provide to, which will actually be used to go and collect performance data on the monitored database. And that user ID needs to have system admin privileges on the database. But you can also set up different kinds of users who will have access only to the OPM console in terms of features like can the user only view the performance data, or can they use the WLM dashboard to actually set up WLM superclasses and subclasses on the database, or can they set up databases itself for monitoring? So that's the second set of users that you can create on OPM. But the user ID, which you provide on OPM to actually say use this user ID to collect performance data on OPM on the monitor database, that needs system admin privileges. What are the other protocols OPM support? I'm not sure I clearly understand that particular question on what are the protocols OPM supports. I'm guessing that's more in terms of the extended insight piece that this question is being asked. We have general connectivity protocols that are set up. Since I mentioned that we only monitor the DB2 as the only database product that can be monitored using OPM. So with respect to database connectivity, yes, it's only DB2. But with respect to application servers and other things, we have you can connect using EI to SAP workloads or WebSphere workloads as well. And how is OPM different from other off-the-shelf performance monitoring tools like Load Runner, open source tools, etc.? OPM is the one which works with the DB2 development team and captures almost every performance metric that can be captured on database performance. This is the best tool that is available with respect to DB2 performance measurements in identifying and diagnosing issues with respect to DB2 databases. I hope that answers your question, Shantanu. In case I haven't, you can probably resend me the question and then I can try to answer that. There is another question that I see from Valar. The question is there any roadmap that Optim will start supporting Oracle or MySQL? At the moment, yeah, we are not in a place where we can start supporting Oracle or MySQL or other databases, but maybe down the line this could come up, but at the moment, no. There is no roadmap as of now to support the other database products. The next question that I see is from Bandaru Jaiprakash, which is, what is the latest version of OPM? The current latest version that is available for users to download and use is the OPM 5.2 version, but the GA version of OPM 5.3 should be up in about a week, 2 weeks time period. The last image creations are currently underway. So in a couple of weeks, we should see OPM 5.3 being released along with the latest version of DB2. The next question that I have is from Shubhra Jyoti De on the cost of OPM product. Shubhra Jyoti De, if you have license for DB2 Advanced Edition, Advanced Enterprise Server Edition, or AESE in short, OPM and various other tools that I mentioned like OCM and other products, the licensing is packaged along with it. But if you're looking for the standalone version of OPM and you have a different version of DB2, please drop in a mail to me. My email ID is on the presentation, which is sn.madhav@in.ibm.com, and I can connect you to the right sales folks on the IBM side for working out the cost figures. Mangesh has a question on, does OPM, is it expected to extend support for Oracle databases in the nearest future? Like I mentioned for the question from Valar, at the moment there is no roadmap to support any other database other than DB2. But of course, if there is any such change, I shall be more than happy to inform the attendees of this particular session. I'll keep them informed if there's any change on that. The next question from Bandaru Jaiprakash was on, is this tool comes along with ESC of DB2 9.7 or later? Bandaru, the OPM tool and various other tools like OCM, OQT, they are bundled with AESE or Advanced Enterprise Server Edition version. So for ESC, OPM is not packaged at the moment. Okay, there's a follow-up question from Shubhra Jyoti De on, can we get any free live training on OPM? Shubhajyoti, you could probably drop in a mail and then I could ask my sales and marketing team to get in touch with your organization and see what training can be set up for your team.
Those were the only questions we had.
There's also a red book available on Redbook.
Yeah, you can
sorry,
continue,
Mohini,
you can continue.
There is a website called redbooks.ibm.com where you will find a very good red book written on the various functionalities of OPM, how you can use it, and various features in detail. You can search for Optim Performance Manager on the Redbook's website, and you can download that book, which is free of cost. There is a newer version of that which is in the pipeline, but the current version that is available should give you a great detail on the various capabilities of OPM itself. Yeah, so that's it from my side, Mohini. I do not see any other questions on the
We just have one more question.
Okay. The next one comes from Bandaru Jaiprakash. The question is this tool consumes a lot of resources on DB2 server in terms of CPU and memory? Bandaru, the quick answer is it depends. I wouldn't say it increases straightforward by some 20%, 30%, but yes, there is certainly an overhead, but the overhead would be minimum because starting the way that I mentioned,
That was the last question for the session, Mr. Madhav. I hope our attendees got commendable insights into their questions. Thank you so much for the session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this session would be available on techgig.com by evening. Thank you all. Have a great day.